let's look at this question. The flask below contained oxygen, in the form of course, elemental oxygen, O2, gas, on the left at 1 atmosphere and 0 degrees Celsius, and on the right at 100 degrees Celsius. So ice water and boiling water here. What is the pressure at 100 degrees Celsius? Okay, so if we look at that, this is a closed system. So N is going to be constant. No gas is going to escape. So N is constant. And also, except for a small amount of thermal expansion, the volume of this flask won't change. So V is constant for all practical purposes. Okay? So that means that our pressure and the temperature are the variables. P1 is 1 atmosphere. And T1 is 0 plus 273 equals 273 kelvins. Okay. P2, we don't know. T2, we do know. 100 degrees Celsius plus 273 equals 373 kelvins for T2. So, if we do the usual thing, P1 V1 over N1 T1 equals P2 V2 over N2 T2. Why am I not using the ideal gas law? Because there's a change. The temperature goes from 0 to 100. Don't use ideal gas law when there's a change. Use a combined gas law. You'll be better for it. N is constant, so we can slash through N1 and N2. And the volume's constant, so we can slash through V1 and V2. So this thing boils down to P1 over T1 is equal to P2 over T2, and we want to solve for T2. And this is not one of the gas laws that we looked at, is it? They all involve volume change. This one doesn't. So we sort of derived a new gas law starting with this P1 V1 thing. Okay? A working form that in its simplest sense will allow us to do the calculation that is needed. So P2 is equal to P1 times T2 over T1. And P1 is 1 atmosphere times T2, which is 373 kelvins, over 273 kelvins. You have to remember not to use the Celsius temperature. You will get nonsensical results if you do, and probably there will be one of the multiple choice answers that fits it, whatever it is. When you do the arithmetic for this, or at least when I did it, I got 1.37 atmospheres for P2. Questions? Yes, go ahead. Yeah. If there's any change of any of the 4 variables, use the combined gas law. It will save you grief. Okay? I'm not saying it's impossible to use the ideal gas law. What I'm saying is it'll add more steps and more opportunities for errors. Okay, now there is a little addendum to this. It says, what pressure would be exerted if the vessel were transferred to an oil bath and heated up to 200 degrees Celsius? And I'll let you do that as a little homework exercise.